All right, nines, I got a request for one of the homework questions for video, page 342, number 9. So let's take a quick look at the question. So we have two students who are walking at constant speeds in front of two motion sensors. So Lucas starts at a distance of 6 meters, and after 10 seconds, he is 1 meter away from his sensor. And Myrna starts at a distance of 2 meters, and after 8 seconds, she is 6 meters away from her sensor. So if we take a look here, it looks like we have time and meters, and here we know that it starts and the meters. And Myrna starts at 2 meters, and then after 8 seconds, she is 6 meters away from her sensor. And we need to find a distance time equation for each walker. So if we think about these numbers, right, we know it's going to be distance time, and we know that the distance depends on the time. So I'm just going to create a table for Lucas, and I'm going to do time, and I'm going to do distance. So when he starts, that means the time is 0, and he is 6 meters away. And then after 10 seconds, so 10 seconds, he is 1 meter away. And then if we do the same thing for Myrna, we know that, again, it's going to be time and distance depends on how long he's walking or she's walking for. So we know at the start she's 2 meters away. So at the start she's 2 meters away, and after 8 seconds she is 6 meters away. So we have two tables now, so we can actually come up with equations for both of them. So let's start with Lucas. Well, we know that we need to figure out the slope. So in order to figure out the slope, again, we are going to subtract the y's over the difference in the x's. So we pick a point, so we're going to make this one y2, so y is 1 and x is 10, so it's going to be 1 over 10. And then we're going to subtract the other point, and y is 6 and x is 0. This is going to be 6 over 0. And so 1 minus 6 is -5, and 10 minus 0 is 10. And we know that we need to reduce this. So I'm just going to come over here to reduce it. I'm just going to put a little line so I know that it's not part of my work. So I have -5 over 10. Well, when I want to reduce it, I've got -5, and I know that 10 is the same thing as 5 times 2. So now I can divide my 5, so that becomes 1. So I'm left with -1/2. So I have reduced this fraction to -1 over 2. So that means that Lucas's equation is going to be y equals -1/2 x. And in this case, I'm very lucky. I already know the y-intercept because I know that when x is 0, that y is 6. That has to be the y-intercept. So I'm going to add 6 to this equation. So y equals -1/2 x plus 6. So now I'm going to start to work on Myrna's equation. So again, I know that for Myrna, okay, that she has also got 2 points, 0, 2, and 8, 6. So I can use my slope equation. So in this case, I take the second y, so 6, and over the second x, which is 8, and then I'm going to subtract this first set of coordinates, so the y is 2, and the x is 0. So 6 minus 2 is 4, and 8 minus 0 is 8. And so again, I want to reduce this, so if I just come over here, and I have 4 over 8, well, I know that's equal to 4, and 8 is equal to 4 times 2. So I can divide the 4's. So 4 divided by 4 is 1. So I know that reduces to 1/2. So I'm going to write 1/2. Again, I'm very fortunate in that I already know the y-intercept for Myrna because the y-intercept is when time is 0. So in this case, my y is going to equal 1/2 x, and when time is 0, distance is 2, so plus 2. So I now have both of my equations, the equation that models Lucas's behavior and the equation that models Myrna's. So part B says, at what time were they the same distance apart? Okay, so I'm just gonna do B right here. So in order to figure out when they're the same distance apart, well, y represents distance and x represents time. So I can write this on my paper, y equals y, because that has to be true, right? These two things are exactly the same. Well, the nice thing about this is that I also know, right, that here y and negative 1/2 x plus 6 are exactly the same. So I can replace one of my y's with negative 1/2 x plus 6. And then I also know, so that's the one equation, that over here, Myrna, I know that her y is equal to 1/2 x plus 2. And because they're equal, they're the exact same thing. So then instead of writing y, I can also write 1/2 x plus 2. So I'm going to replace hers with 1/2 x plus 2. And so all of these things are true, right? Y has to equal y, they're the exact same thing. But I also know that y equals negative 1/2 x plus 6, and I know that y equals 1/2 x plus 2. So I've taken this 1/2 x plus 6 and used it over here to replace this y, and I've taken this 1/2 x plus 2 and put it here to replace this y. So they're all the same thing. Well, now I have an equation in terms of x's, and I know x is my time, so I can just solve. So here I have negative 1/2 x plus 6, and here I have 1/2 x plus 2, and I need to get x's on one side and numbers on the other, so it just goes back to solving equations, which we did last unit. So I'm going to get rid of the negative one because I personally don't like to work with negatives. So that means that I am going to add 1/2 x plus 2 to both sides, or sorry, 1/2 x to both sides. So I'm going to add 1/2 x to that side, and I'm going to add 1/2 x to this side. Well, negative 1/2 x plus 1/2 x is 0, so I'm just left with 6, and 1/2 x plus 1/2 x is 1x, and then I have plus 2. And so now I want to get rid of the 2, so I'm going to subtract 2 and subtract 2, so I have 4 is equal to x, and then if I write that down, well, this is time, so I know that 4 seconds is equal to x. So therefore, I have figured out that after 4 seconds, they'll be at the same distance. And then the last part of this question says, it says, now, how far will they be from the sensor? And that's actually the easiest question in this whole long question, because at this point, if we know how far they are, so we know at what time they're the same distance from the sensor, so in this case that's 4 seconds, well, we have two equations here that we can plug that 4 seconds into, and it really doesn't matter which equation we plug that into. I'm just going to go ahead and move this up here, and now I'm going to go and do C. So I know that x is equal to 4 seconds, and I know that y is my distance, so I can use either one of these equations. It doesn't actually matter which one, sorry. So I can use this equation to find y, or I can use this equation to find y. Because remember, my y's are equal. So whichever one I use, I'm going to get the exact same answer. So I'm going to use the one without the negative, just because I don't actually, or because it's just easier if you're working, if you're not working with negatives. So in this case, I'm going to replace x with 4 seconds. So I have 1/2 times 4 plus 2. So remember, 4 times 1 is 4 over 2 plus 2. 4 divided by 2 is 2 plus 2. And so that equals 4, and y is measured in meters. So then after 4 seconds, they will both be 4 meters from the sensor. So therefore, after 4 seconds, they will be 4 meters from the sensor. And then you're done. So we're going to be definitely doing a lot more of these problems in the next unit. This is, if you look in your textbook, this is one of the extend problems. It's one of the challenge questions. So it's one of the ones that you want to be trying your best to figure out, because these are the ones that are more challenging. They use different concepts. You have to kind of take something that you've learned and apply it in a slightly different way. And so these are the ones that are the more difficult ones, and the ones that on the test are obviously the more difficult. So the more you try these questions and really like try to figure them out, the easier it's going to be in test situations when you're stuck trying to find answers to hard questions. You'll start to see patterns the more of the challenge questions that you do. Anyway, I hope this helps.